Okay, welcome everybody. So today we're going to be talking about neutralization reactions. So first off, what is a neutralization reaction? So neutralization is when we take an acid and a base and they react and they form water and a second product known as salt. Now that doesn't automatically mean NaCl. When we say salt in chemistry, it's any ionic compound that's the product of an acid-base reaction, okay? So we've been talking a lot about acids and bases lately. The ion that makes something an acid is hydrogen, right? According to Arrhenius, hydrogen ions make something an acid. And hydroxide ions, according to Arrhenius, make something a base. And when they get together, HO, we end up with water, which is neutral, right? So that's where neutralization comes from. We take something acidic and something basic, and we put it together to make neutral water and salt, okay? So neutralization occurs when we have hydrogen and hydroxide in equal amounts so that they become H2O, okay? So when a solution is neutral, we end up with exactly the same amount of acid and base. We can calculate the amount of acid or base necessary to neutralize something by keeping that in mind. We need equal amounts of hydrogen and hydroxide. Okay, we have to have the same number of moles of hydrogen as hydroxide. And at that point, we'll have a neutral solution. So here's an example problem. What volume of 0.10 molar hydrochloric acid is required to neutralize 50 milliliters, go ahead and put a decimal there for sig figs, okay? 50 milliliters of 0.12 molar magnesium hydroxide. All right, so same thing we always do. We're gonna have to figure out a volume of hydrochloric acid. So they're asking us for volume. That's gonna be liters or milliliters. I'm gonna go with milliliters this time. And we're given information, right, about this base. We have 50 milliliters of 0.12 molar magnesium hydroxide, okay? So that part right there is what we're trying to neutralize. So there's my given amount, okay? First thing we gotta do is write a balanced equation between hydrochloric acid and magnesium hydroxide. Now it's the hydrogen and the hydroxide that react to form water. So I'm gonna use that and I'm gonna make water out of it. And then what's left is magnesium and chlorine. So magnesium chloride is the second product. Now on the periodic table, magnesium is an alkaline earth metal with a charge of +2. Chlorine has a charge of -1. So we need 2 chlorines to bond with magnesium. So MgCl2 is the salt that forms during this reaction. If I put a 2 there to balance for charge, I need to put a 2 here to balance for atoms. And then I have 2 hydrogens here and 2 hydroxides here. We're gonna end up making 2 water molecules. Okay, so there is the balanced equation for the reaction. So next, we have to calculate something called millimoles. This is something new. We've used moles before, we just haven't used millimoles before. And honestly, millimoles is really easy. Let me draw the triangle. This should look familiar. Okay, remember this? This is the molarity triangle. Well, molarity, okay, is usually when we have moles over liters. Well, if I leave milliliters, then what goes on top is gonna be millimoles. Okay, so when we're working with these small amounts, sometimes it's a lot easier to work with whole numbers as opposed to decimal numbers. So instead of converting everything, we're gonna leave it milliliters, and then the number of moles we get, we're gonna call millimoles. At the end, when we take millimoles and divide it by milliliters, we'll still have molarity, so it works out mathematically, okay? So what did we have? We had 50 milliliters, okay? So I'm gonna take my milliliters. It was 0.12 molar magnesium hydroxide, so I'm gonna multiply it by the molarity, and that's gonna give me millimoles. So when I multiply these two things here, that's gonna give me millimoles of magnesium hydroxide, okay? So I have 0.12 molar solution, okay, and I have 50 milliliters of it, okay. So that gives me, let me go ahead and multiply that real quick. That gives me 6 millimoles of magnesium hydroxide. Okay, well, so here's the deal. I'm going to do a little stoichiometry here for a second. I have 6 millimoles of MgOH2. Okay. I know that for every 1 millimole of this, we need 2 millimoles of hydrochloric acid. So I'm just using a mole ratio, in this case a millimole ratio, but it's the same thing, right? For every one of these, I need 2 of those. Which means I'm gonna need 12 millimoles of hydrochloric acid, right? 6 times 2 is 12. Okay. So if I need 12 millimoles of hydrochloric acid, okay, let me flip back over, okay? 12 millimoles of hydrochloric acid. And in the problem, it told us that the hydrochloric acid had a molarity of 0.10 molar. Okay, so once I know how many millimoles of hydrochloric acid are necessary, then I can just take that and divide it by the molarity, and I'll end up with milliliters. Okay, so millimoles divided by molarity is going to give me milliliters. Okay, so again, we need 12 millimoles of hydrochloric acid, and I know that it is 0.10 molar. So I'm just going to take my 12 millimoles and divide it by 0.10, and that's going to give me the milliliters that I need. So 12 divided by 0.1 gives me 120. That's 2 sig figs, so we can keep that. Okay. All right, so you could use kind of the solution stoichiometry that we were doing in the last unit, right? Our known amount, right, was given to us as an amount of magnesium hydroxide. We did some stoichiometry to figure out how many moles that was, and then used the mole ratio to figure out how many moles of hydrochloric acid we needed. Then we used this kind of modified molarity triangle to figure out milliliters. So this is one way to approach this kind of problem. But another way to do it is to just say to ourselves that we need our hydrogen concentration to be equal to our hydroxide concentration. And if we know from the triangle that molarity times volume will give us moles, molarity times milliliters will give us millimoles, then we can just take the molarity of the acid, we can take the volume of the acid, right, in milliliters, and multiply those two things, and we'll get moles of acid. And then we can set that equal to moles of base by taking the molarity of the base and multiplying it times the volume of the base. Does this look familiar? It should look kind of like the dilution formula, right? Okay, so if I want an equal amount of hydrogen and hydroxide so that it's neutral, then I can take the molarity of the acid and multiply it by the volume of the acid and set it equal to molarity of base times volume of base, fill in these blanks, and then do some algebra to solve. Now the only thing here that'll kind of set things incorrect is the fact that we actually needed twice as many hydrochloric acid because we had a mole ratio. So one way to fix this is to think about the normality we did in the last set of notes. Remember that we took the molarity of the acid, and let's say it was a diprotic acid, right? If it had 2 protons, Then we took that and multiplied it by the number of hydrogens per molecule, okay? We can do that with the base as well. I can take the molarity and volume and multiply it by the number of hydroxides, okay? And that'll actually calculate what we call normality. And I can set the number of hydrogens equal to hydroxides this way. So just to be clear, let me go ahead and solve this same problem, so same exact problem, using this equation instead, okay? The molarity of the acid times the volume of the acid times the number of hydrogens per acid equal to molarity of base times volume of base times the number of hydroxides per base molecule, okay? So the molarity of the acid was 0.10 molar, right? That's what they told us in the problem, 0.10 molar hydrochloric acid. And they asked us what volume, so this is gonna be my unknown. So volume of acid is unknown. Now in hydrochloric acid, there is 1 hydrogen per molecule, okay? Now the molarity of the base that they gave us, they said it was 0.12 molar magnesium hydroxide. We know that we have 50 milliliters of it from the problem. And there are actually 2 hydroxides because it's MgOH2. There are 2 hydroxides per molecule. So now all I have to do is multiply and divide, okay? So I'm gonna go ahead and multiply this side of the equation. So 0.12 times 50 times 2. And I end up with 12 on this side, okay? And then I can do 0.10 times 1, so again, that's gonna be 0.10, correct? Times the volume of the acid, okay? So that's the other side of the equation. Now to solve for the volume of acid, I need to divide both sides by 0.10. So that cancels out. Gotta divide by 0.10. Does that look familiar? Isn't that the math we just did up here, right? 12 divided by 0.10. We're gonna end up with the same thing. We're gonna end up with 120 milliliters. So if the solution stoichiometry way of solving this was a bit confusing, use this equation, okay? Molarity times volume times the number of hydrogens for the acid equal to molarity of base times volume of base times the number of hydroxides per base. Okay, fill in all the pieces of information that are known and then do algebra to solve for the unknown, okay? Hello, welcome. So I'm going to show you how to do a couple neutralization problems. Remember, you're using this equation. Okay, so if we look at the first problem, what volume of 0.1 molar sodium hydroxide is required to completely neutralize 50 milliliters of 0.25 molar hydrochloric acid? Okay, so if we fill in the information we know, the molarity of the acid, 0.250. The volume, 50 milliliters. And if we look at the formula for hydrochloric acid, there is 1 hydrogen ion per molecule, okay? On the other side, the molarity of the base, 0.100. We don't know the volume, but the formula for sodium hydroxide contains 1 hydroxide ion. So then the first thing you do is multiply 0.250 times 50 times 1. So 0.250 times 50 times 1 is 12.5. On the other side, we have 0.100 times the volume of base times 1. So that is 0.100 times the volume of base. So in order to solve for the volume of base, you should divide by 0.100. Whatever you do to one side, do to the other. Divide by 0.100, and you end up with 125. That's 3 significant figures, and so are each of the values we're given. So we're going to keep 3 significant figures in the answer. Okay, so that's how you do the majority of the problems on this worksheet. For questions 7, 8, 10, and a few on the back, they're going to be a little bit different. So if you look at these problems, they actually give you the volume and molarity of the acid and the volume and molarity of the base. What they're asking is the pH of the resulting solution. So the first thing we need to do is calculate how much acid we have and then calculate how much base we have. And we use the same idea. We have 50 milliliters, so there's the volume, of 0.100 molar acid, which has 1 hydrogen ion. So that's 5 millimoles of H+. We have 75 milliliters of 0.100 molar sodium hydroxide, which has 1 hydroxide ion. So that is 7.5 millimoles of hydroxide. Now what happens is the hydrogen reacts with the hydroxide to form water. And if we look at it, the hydrogen is going to run out first because there's only 5 millimoles. So 5 millimoles of hydrogen is going to react with 5 millimoles of hydroxide. And when that happens, we're going to have an extra 2.5 millimoles of hydroxide left over. Now, we put two solutions together. We put 50 milliliters of acid in the same beaker as 75 milliliters of sodium hydroxide. So if we think about the total volume, 50 milliliters and 75 milliliters, if we put them together, that would be 125 milliliters of solution. So we have this much extra base sitting in 125 milliliters total solution. And this is millimoles. So millimoles divided by milliliters should give us molarity. 2.5 divided by 125 gives us a molarity of 0.02. Now that's the molarity of hydroxide that's left over in the solution. So from there, you should be able to negative log, and you get 1.7. Okay, so the POH, because you just negative logged an OH concentration, is 1.7. 14 minus that answer gives you 12.3. So the pH of this solution would be 12.3. And that's how you do those other problems where it asks about pH. Calculate acid, calculate base, figure out the difference between the two. That difference divided by the total volume will give you molarity, and from there you can calculate pH.